High up in the dense canopy of South America, a highly successful, aggressively expanding species has built a stronghold. Decades ago, African days brought to Brazil for an experimental crossbreeding program escaped. They spread rapidly across the continent, carving out territory in the wild. What they built is a heavily fortified superorganism. Inside, hundreds of thousands of insects move in constant, chaotic sync. No single insect matters here. Individuals are entirely expendable components fueling a larger, breathing machine. When a new worker pulls herself out of the wax comb for the first time, her role is instantly assigned. She doesn't need to learn a purpose. Her sole biological mandate from the moment she hatches is to maintain and defend this fortress. Her colony possesses a specific evolutionary trait that separates it from almost every other insect on the continent. Their biological response to any perceived threat is vaster, hotter, and exponentially larger than that of any other bee alive. By all conventional metrics, this brute force defense system works flawlessly against massive trauma. Yet this supposedly impenetrable colony will ultimately be wiped out by an enemy that simply walks right through the front door. At 3 weeks old, a worker takes her position on the front line. She stands at the entrance as a guard, checking the chemical markers and vibrating signals of every single insect attempting to land. If a bee drifts in with the wrong markings, the response is instant. Before the intruder even touches down, the guards surround it. They press in tight, vibrating their bodies together to generate intense heat, literally cooking the foreign bee alive within seconds. This lethal aggression extends to how they claim territory. When the swarm needs a new home, scouts might target a hollow tree already occupied by a colony of small, stingless bees. The swarm floods the space, overwhelming the native insects and violently tearing their comb off the walls to clear the cavity. At this micro level, the hive operates a perfectly ruthless perimeter. It is entirely proactive, instantly identifying and neutralizing isolated threats to secure its immediate surroundings. Once a worker graduates to a forager, the operational zone shifts outside. The open air is full of ambient, persistent dangers. Crab spiders sitting absolutely still on flowers, and robber flies that drag foragers into the undergrowth mid-flight. Soon, the hive faces a coordinated threat. Robber bees from a larger neighboring colony probe the entrance early in the day. The guards repel the first few, but by the afternoon, the robbers return in waves, launching a full-scale, sustained assault to steal honey. The landing board turns into a battlefield. Defenders and invaders crash into each other, locking legs and driving stingers into soft undersides across the entrance gap until hundreds stop moving. The hive loses a huge portion of its workforce and its honey stores, but it recovers quickly. The queen ramps up her laying rate, churning out thousands of eggs in the days that follow. She treats worker lives as a highly expendable, easily replenishable currency. When faced with pair-level warfare, the colony functions as a massive, resilient sponge. It can absorb severe structural damage and immense biological casualties, surviving the siege purely through extreme reproductive output. The ultimate test of this defense system comes from the jungle floor. Massive mammalian predators continuously roam the undergrowth, actively searching for vulnerable prey and sweet calories. A honey badger locates the dead tree housing the hive. Relying on thick fur and raw physical strength, it claws violently at the bark, widening the entrance to rip out large chunks of waxcomb with its teeth. Inside, a chemical alarm cascade triggers instantly. A massive, furious cloud of thousands of bees erupts out of the dark cavity, swarming the predator and blanketing its head and shoulders in stingers. To penetrate that heavy armor, the bees employ a very specific tactic. They bypass the dense fur entirely and seek out the thin, soft skin at the corners of the mouth and directly around the eyes, maximizing the pain until the animal finally retreats. The cost of repelling the attack is staggering. Hundreds of bees die instantly, crushed by the predator's paws as it scratches its face, or left scattered on the ground, their abdomens ruptured as their stingers tear free. Against the largest, most violent external threats, the colony's brute force defense operates exactly as designed. It readily sacrifices vast numbers of individuals, to ensure the genetic core of the hive survives intact. At 4 months old, the colony has survived predators, rival hives, and the elements. It appears invincible. But a completely different kind of threat quietly enters the system. Parasitic foam mites hitch a ride directly on the backs of returning pollen-laden foragers. Because they are perfectly positioned on their hosts, they slip past the tightly packed entrance guards without triggering a single alarm. The colony's famous hair-trigger aggression is utterly useless here. The guards are trained to search for massive shapes, foreign movements, and incorrect chemical signals. They cannot sting a threat they cannot detect. Once inside, the mites bypass the workers, crawling straight into uncapped brood cells to hide beneath developing larvae. By embedding themselves in these sealed cells, they turn the hive's constant flow of warmth into an incubator for their own destruction. The physical toll on the next generation is catastrophic. When the infected young chew through their wax caps, they emerge with bent wings and crippled legs. They drag themselves across the comb, entirely unable to fly or forage. This chart shows the lethal cascading cycle that follows. A crippled generation means fewer healthy foragers to gather food. Less food means fewer healthy larvae develop, which ensures even fewer replacements can survive the next cycle. The hive's ultimate fallback mechanism fails. The queen continues to lay eggs frantically, trying to spend her way out of the deficit. But the speed of the systemic collapse severely outpaces her production line. Eventually, the workforce is gone. One of the last surviving foragers returns to an unguarded entrance. She unloads her pollen into an empty cell, folds her legs against the wax, and stops moving. Biological brute force has a strict limit. This colony perfectly evolved to defeat visible external enemies. But in nature, the deadliest threats don't need to break down the door. They silently dismantle the system from within.